Okay, so I know that I have promised you this for a little while, but I'm finally making it. Here is your tutorial on the unit circle. Okay, so you've seen this before. This is your unit circle. Remember, it has a radius of 1, thus the unit circle. And it shows you values of sine and cosine for different angles. And it is a bit much to memorize the entire thing. But really, the important things to notice about this, we have the quadrant angles, which are the ones that make the crisscross on the axes. So those are here. So in blue, I'm circling your quadrant angles. And in degrees, that would be 0 or 360 degrees, 90, 180, and 270 degrees. In radians, you have 0 or 2 pi, pi over 2, pi, and 3 pi over 2. So those ones you should memorize. So the quadrant angles are at 1, 0, 0, 1, negative 1, 0, and 0, negative 1. That's not so bad. It's all zeros and ones. But this other stuff in the middle is just too much. So we have 30 degrees, which is pi over 6, and then a bunch of other pi over 6s. And what you should know about all the pi's over 6, so pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, is that the reference angle for each of these, so if we drew a triangle, the reference angle for each one is 30 degrees. Okay? And the way that I remember that is I know that 180 degrees is pi. So if I divide by 6, pi over 6, well, 180 over 6 is 30 degrees. So we're really looking at 30-degree angles for each of these. If you look at the reference angle then for pi over 4, okay, so we have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. For all pi over 4 angles, your reference angle is 45 degrees, okay? So, and again, 180 over 4, because we have pi over 4. 180 over 4 is 45 degrees, okay? And then my pi over 3's. So we have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. If I take 180 degrees, it's equal to pi, divide both by 3, and I get 60 degrees is pi over 3. Okay, so really, aside from the quadrant angles, again, which are circled in blue, you have 3 reference angles that you should have memorized. So 30, 45, and 60 degrees, which are pi over 6, pi over 4, and pi over 3 in radians. Personally, I think that it is easier to memorize my 2 special right triangles than trying to memorize the entire unit circle. You could, and if you were to do that, I recommend memorizing just this first quadrant. So you can memorize these numbers out here on the outside and then figure out the signs. Because the only thing that's changing as you go around the circle are the signs of your x and y coordinates. But I really do think it's easier to memorize my special right triangles. So here I have a 30, 60, 90 degree special right triangle. And the ratio of the sides of a special right triangle is 1, 2, square root 3. Okay? So the 1 is the smallest number here. It goes across from the smallest angle, which is 30 degrees. 2 is the biggest number here, okay? Because square root of 3, you know square root of 3 is less than square root of 4. Well, the square root of 4 is 2. So the square root of 3 is less than 2. 2 is the biggest number. It goes across from the biggest angle, which is 90 degrees. So I like to remember this. I have 1, 2, 3 different angles and 1, 2, 3 different side lengths. 1, 2, square root 3. 1, 2, square root 3. And from here, all you need to use is SOHCAHTOA. So remember, sine is opposite, divide by hypotenuse. Cosine is adjacent, divide by hypotenuse. And tangent is opposite, divide by adjacent. SOHCAHTOA. So for instance, if I wanted to find, let's look here, if I wanted to find sine of pi over 6, well, I already showed you how I figure out pi over 6 is 30 degrees. So I'm going to do 30 degrees, opposite is 1, hypotenuse is 2. So basically sine of pi over 6 is 1/2. Easy. So this triangle you would use for anything with a pi over 6 and anything with a pi over 3. So pi over 6's, you're using the 30 degree angle. Pi over 3, you're using the 60 degree angle. But you're probably asking yourself, well, what about the different signs that you mentioned? Well, here, maybe I didn't have pi over 6. Maybe I had 5 pi over 6. Or maybe I had, let's do 11 pi over 6. Okay, so maybe I want to find sine of 11 pi over 6. Well, again, I know I have a 6 in the denominator here, so I say 180 over 6 is 30. So I'm using my 30 degree angle. Cool. And then you probably also remember hearing this acronym a few times. We're labeling our quadrants based on who's positive where. So all students take calculus, of course. So all students take calculus. Remember that A means that all of your trig functions are positive here. All. The S means that sine and cosecant are positive. Everyone else is negative. T, tan and cotan are positive. Everyone else is negative. And C, cosine and secant are positive. Everyone else is negative. So this is what we're using. Now, I know that 11 pi over 6 is in this quadrant. How do I know that? Well, basically 12 pi over 6 is 2 pi. And we're only 1 pi away from that. So I just know it's going to be right there. Yeah. So memorize where the locations are, I guess. Or, yeah. 11 pi over 6, you could think of it this way also. 11 pi over 6 is greater than 1 pi. You know that because 11 is bigger than 6. So it's either in the third or fourth quadrant. But it's closer to 2 pi than it is to 1 pi. So it's in quadrant 4. So I'm using this here. And I know that it's going to be, well, the same as sine of pi over 6, which is 1/2. But then I'm using this and saying, well, this is in quadrant 4 though, and only cosine and secant are positive in quadrant 4. And I have a sine. So really, this isn't 1/2, it's negative 1/2 because of the quadrant that I'm in. Okay, so that takes care of the 30 degrees and the 60 degrees, so pi over 6 and pi over 3, but we still have all these things in green here, so pi over 4s. So let's look at pi over 4. You probably remember from geometry that your other special right triangle is the 45, 45, 90 triangle. Like this. And remember that 45 degrees is pi over 4. Okay? So this is really pi over 4. And again, we can use SOHCAHTOA here because we do have a 90-degree angle. The ratio of the sides of a 45, 45, 90 triangle is 1, 1, square root 2. 1, 1, square root 2. And again, just like the other one, I remember I have 2 different side lengths. 2 different side lengths. There are 3 sides, but these 2 are the same. So 2 different side lengths. So I have 2 different numbers. And I'm just counting up. 1, 2. The last thing you always have is always square root. So 1 square root 2. Okay, so now let's say that we want to evaluate one of these angles. Maybe I want to find tan of 5 pi over 4. So tan of 5 pi over 4. What I need to do first, well, I'm going to say 180 over 4 gives me 45. So I'm using my 45, 45, 90 triangle. And let me just look here and label. So I know tan is opposite over adjacent. So that gives me 1 over 1, which is 1. And then I need to figure out which quadrant am I in. So let's figure that out. So all students take calculus. And I know 5 pi over 4 is down in quadrant 3 because I can just count up by 2's there. I have pi over 4, 3 pi over 4, 5, and 7 pi over 4. So I'm in quadrant 3, which is tan's quadrant, which means that my answer is positive. Okay? And tan isn't on the unit circle, which I think is another advantage to doing this way instead of just looking at the unit circle. But if I divided, remember tan is sine divided by cosine, I would get a 1 because those are the same exact number. Okay, so this is how I like to do trig instead of using the unit circle. I think it is easier. And again, all you have to memorize are your 2 special right triangles and which radians go with which degrees, and then the signs. Okay, oh, and also don't forget those quadrant angles, but basically that is the unit circle.